students. In our previous video, we studied about the physical quantities. Those are the fundamental quantities. We have 7 fundamental quantities, and corresponding to them we have 7 fundamental units. For mass it is kg, length meter, time second, current ampere, temperature Kelvin, luminous intensity is candela, amount of substance is mole. Now for the process of the dimension analysis, we have some symbols. In place of these units, we will use some symbols. For kg, mass m, for length meter we use L, for time we use T, for ampere A, for Kelvin K, candela CD, mole. So the very simple method to remember the 7 physical unit, the base unit, mLt AK candela mole. Once again, mLt AK candela mole. mLt AK ये आपको थोड़ा सा ज़्यादा यूज करना होता है. So we have mLt AK candela mole. So we have to write the other quantities in terms of mLt AK candela mole. As I told in my previous lecture, we have 7 fundamental the quantities and fundamental unit. All the other units are derived with the help of these base units known as derived unit. So we have to find out कि in order to derive a given unit, which one and how many times the base quantities have used. For example, we have Newton, Joule, Watt, Pascal, Coulomb, Farad, Volt, etc. So many we have the derived quantities. So now we have to find that which one and how many times base quantities are used in order to derive a given derived quantity. So we start from the first one, that is Newton. So Newton is a derived quantity. Newton is formed by these fundamental units. We know Newton is the unit of force. Force equal to mass into acceleration. Mass, the unit is kg, and acceleration, we know acceleration is the rate of change of velocity. Its unit is meter per second square. So finally the Newton, the meaning of Newton is kilogram meter per second square. This line we can say the derivation of Newton in terms of the base quantities, base units. Now if we use symbols in place of kg, meter and second, so for kg always m, mass, for meter length L, and time t second. So and when we raise the power on these symbols, for Newton mLt minus 2. So this is known as the dimensional formula of a given physical quantity. Here powers, these parts known as dimension. Here dimension of kg is 1, length is 1, and for time is minus 2. So this here for force mLt minus 2 is known as the dimensional formula. Okay. The next one is work. We know work is a quantity whose unit is joule, and we know formula work equal to force into displacement, and here we prove for force mLt minus 2. So here we can use simply mLt minus 2, displacement in length, so L, here L to the power 1, L to the power 1, in multiply we add the powers. So 1 and 1 power 2. So for work ml to t minus 2. Actually this ml to t minus 2 is the dimensional formula for joule, not for work. Whenever there is a joule, it means dimension formula will be ml to t minus 2. We know joule is also used for energy. Kinetic energy we know half mv square. For half there is no dimension, mv square. For mass is kg, and velocity, rate of change of displacement, it means meter per second. So its whole square So supplying this square here also. So kilogram meter square second square by using the symbol for kg meter, for meter L, and for time T. So ml to T minus 2 again. The same formula of joule by work and by kinetic energy. Same we can derive with the help of potential energy also. We know potential energy formula mgh, m mass kg, g stand here for gravitational acceleration, and we know acceleration is meter per second square, h means height for meter. Here meter into meter become meter square, so kilogram meter square per second square, applying the symbols ml to T minus 2, also joule. It means whenever joule, and from this we can say work equal to kinetic energy equal to potential energy, pressure energy also P into V, pressure into volume, equal to joule ml to T minus 2. So in this way we can discuss, we can derive all other the derived unit in terms of base unit by the dimension analysis. Thank you.